This concept is a set of rules that describes or governs the motion of objects in the realm of classical mechanics, or rather objects that are relatively big and slow. Big in this sense isn't restricted to objects on the scale of planets. The laws work perfectly for scenarios such as sports or transportation. Big simply means bigger than looking into the makeup of matter and objects. Slow also isn't limited to very low speeds, just significantly lower than the speed of light. There are a few methods that teachers may turn to for the purpose of developing an understanding of their students' previous knowledge. One option, which is favorable for its simplicity and the opportunity for creativity, is a concept map. Students are also usually comfortable with this type of activity, as most of them have likely seen and dealt with these types of illustrations or diagrams before. I believe that this option would be the ideal choice for the concept of Newton's laws of motion due to the fact that the laws basically describe the relationships between key physics terms such as velocity, acceleration, and force. Another method that could potentially be useful may be a pre-concept test. However, students tend to find physics scary for the first time when they see new concepts. There are many facts that they first must learn and understand before they can make any sort of reasonable hypothesis. Therefore, a pre-concept test might not be the best for this scenario, as answers that students would give would most likely be completely random and wild guesses. For the concept map, teachers can list a small group of terms that are directly taken from the course material and have the students draw a concept map. Students would attempt to show the links between terms with arrows to demonstrate their understanding of the relationships amongst them and how each term relates back to the concept at hand. Based off of this exercise, the teacher can form a strong understanding of the student's previous knowledge that they might have gained in previous classes. There is an endless amount of misconceptions that a student may believe to be true related to physics. In my opinion, and in my misconceptions as well, this is mostly because, while students may know the facts and the right answers, which they focus on while studying, they don't always hold on to the explanations, and thus are forced to come up with their own. For Newton's laws, a common misconception is a student hearing that the laws of classical physics, such as Newton's laws, are wrong, and thus they shouldn't be bothered to trust the material, teacher, textbook, or even the school. This would most likely be a result of hearing about things like quantum mechanics from potentially the Discovery Channel, YouTube videos, maybe even their friends or parents. Of course, like I said before, Newton's laws of motion do break down in studying modern physics, but that doesn't make them wrong, and they can still be trusted. As stated on Understanding Science, a website from the University of California Museum of Paleontology, while it's true that all scientific ideas are subject to change if warranted by the evidence, many scientific ideas, for example evolutionary theory, foundational ideas in chemistry, are supported by many lines of evidence, are extremely reliable, and are unlikely to change. In our case, Newton's laws may not be universally true, but they are supported by tons of evidence and are extremely reliable. However, like many misconceptions, the facts and truth may get mixed up with incorrect reasoning. Another misconception is that the mass and the weight are the same thing. Hank Green, in his YouTube video, explains and corrects this misconception by simply describing the relationship. Green defines weight as the measurement of the strength of gravity acting on a specified mass. What this means is that the mass tells us how much matter, or stuff, is in an object, while weight is how strongly gravity is acting on that object. A great method for helping students overcome their misconceptions is a POE demonstration. This stands for Predict, Observe, and Explain. In the journal article titled Addressing Misconceptions, POE is described as a demonstration designed to provide teachers with a way to elicit alternative conceptions relating to a particular concept, allow students to discover why these conceptions are inadequate, present a new explanation supported by evidence, and show them why the new explanation is more useful. For example, if we look at the misconception of mass and weight being the same, we can use a POE demonstration to help correct a student's false beliefs. We can determine the mass of an object, and then calculate its weight on the Earth and on the Moon. The students would make a prediction, potentially saying that the weight would be the same in both cases according to the misconception. We would then observe that it would be false. And finally, the teacher would provide the explanation for why. In the journal article From Misconceptions to Conceptual Change, Gooding and Metz also provide methods for correcting misconceptions. They advise to give our students opportunities for conceptual change. These may take in the form of discrepant events, inquiry-based activities, or other minds-on experiences, and should help students reconstruct and internalize their knowledge. To relate this to my concept, we can look at the first misconception. The feeling of distrust towards physical laws may be brought about from a negative attitude towards physics in general. While I explained how to correct this misconception, it is much harder for conceptual change to come about, as misconceptions may be deeply rooted due to a variety of factors.